Hi there, I'm John English. I'm a member of the Royal Statistical Society Quality Improvement section, and today with Eugenie we're going to go through a scenario where we use quality tools, Six Sigma and Lean to improve the quality of process. I'll hand over to you, Eugenie, just to give yourself a quick introduction.
Hi everybody, I'm Eugenie. I'm a member of the Quality Improvement section of Royal Statistical Society, and I'm also working in a software company that deals with quality statistics. So that's the topic we're going to talk about today.
Yeah, brilliant. Thank you. So just to set the scene a little bit here, so myself and Eugenie are going to take on different roles here. So I'm going to be the role of the production manager who's got a problematic process, and Eugenie is my statistician or Six Sigma expert who's going to help me solve the problem. So to set the scene, see, I'm a production manager. I've got some issues with one of my key production lines. It's not really capable of producing repeatable, good quality product. Specifically in this case, the issue is with the filling process. So I'm experiencing quite a lot of filling rejects on my lines, which is causing me a lot of downtime to try and understand what the issues are with the filling process, but also time taken to back check to understand, okay, how much of my stock's impacted by that. So my filling process consists of 3 independent filling needles, so filling needle 1, 2, and 3, and I've also got parameters that can be adjusted, such as pressure, filling speed, bed position, that can also impact the filling performance of those. And like I mentioned, I've enlisted the help of my Six Sigma colleague, Six Sigma expert, in this case, Eugenie, to try and help you understand this. So we will start and go through it. So we'll have next slide, please, Eugenie. We'll cut that bit out, it's fine.
Oh, right. So
it's all right.
So John, how is it going with your process? So have you already created some graphs?
Yeah, we've got some graphs here that, again, we've created so to understand what happens over time with my process, and also we've got a process capability report here as well to understand what the capability is of my process. What can you, from your mind, what can you say from those?
Well, it's you can see the run chart is not looking great, isn't it? It's there's a lot of variability in the data, and I noticed you've got the 3 colors, and each one represent a particular filling needle. Well, and I can gather that you've got the 2 dotted red line. I guess these are like the limits, the specs for your process. Am I correct?
Yeah, that's all
right. Okay, limits. So right, it doesn't look good here. And well, looking at the capability analysis, you've got a very low CPK and PPK. Well, it doesn't. Well, and also I can see from the graph there. Well, it looks like you've got quite a few items of specs. So no wonder you're seeing problems in your process. So, well. First of all, you've got 3 different needles. I'm just wondering how are you measuring the data? Have you taken a look at the measurement system analysis? Maybe there could be some measurement error there because there's a lot of variability and they're not up to spec. So, but I mean, first of all, before we do anything, we need to make sure our measurement system is measuring our items correctly.
Yeah, it makes sense. We've got a very old measurement system in place of a set of scales that we use, and a lot of different people use those scales. So there's potentially could be some error there between different people using them. So that's definitely a great bit of advice. I think we'll certainly do that now in the next 2 weeks.
Sure. Yeah, I think first of all, it's let's check to make sure the system is working fine, and then we can look into finding out why there's an inconsistency between the different needles.
Yeah, we can do that. Okay, so 2 weeks later on from Eugenie's advice, we have performed an assessment of the measurement system. So what we've actually found was that, like I mentioned before, that we've got different shifts doing it, different shifts looking at different shifts measuring it. We've actually found that some shifts were only measuring to 1 decimal place and others were measuring to 3 decimal places. There's
Oh.
the measurement system itself actually does measure at 3 decimal places. So I'm wondering why the rounding off at 1 decimal place. Obviously, that'll add a lot of variability there as well.
Mm.
Um, but I think one of the key things, though, really, regardless of that, is that some people in some of the shifts are actually just doing the measurements very, very quickly, not letting the scales settle. Like I mentioned before, we've got quite an old set of scales there, which take a little bit of time to stabilize, maybe 5 to 10 seconds. So what we've done, we've understood that. We've got everybody together, gone through with everybody. Everybody understands the process now. We've got a standard work instruction there to standardise that and to put that in place. I've also been walking around just making sure that everybody's abiding by that, and also iron out any other issues people might have with that. So I think everybody's really comfortable, know what they're doing, and I'm happy that that's in place now and that's fixed. So
Oh.
hopefully we might see a difference.
Oh. That sounds great. Oh, let's have a look at the data. Well, this time that's look much better. At least they're all within spec as far as I can see, looking at the run chart. And for the capability, I can see there's an improvement. Well, at least now your process is more centered between the upper and lower specs. And I can see the CPK and PPK, they're both getting closer to the target. Actually, ideally, we want the capability indices to be close to 1.33. And that's the case for CPK. PPK is getting there. It's good to see some improvement.
It's good to see what we've actually done has actually made some difference, which is great. So that's good.
So I guess the next step would be maybe to get the process to get closer to the target, or maybe have you got a target that you want to achieve? Or
so we want to try and hit around the centre of specification, which is around about 1.17. So that's what we want to try aim for.
Right. Oh, I see. Yeah, that's probably, you may want to try it, look at, now you've got a good measuring system. Let's maybe it's time to look at what are the things you can improve in the process.
Yeah, I mean, looking at that there's quite a wide spread, and you can see by the graph.
Yeah,
the colours aren't overlapping, are they? So
yeah, there's a lot of variability. Certainly, there could be some differences between the measurements from the different needles. So it may be worth looking at the variability.
Yeah, that's a good idea. Yeah, I think we'll certainly do that over the next month. We'll look at the how we try and standardise the setup of our needles, because it looks like there's a massive spread between them.
Yeah.
So if we can get them all aligned, that might be the way forward to get an even better process. Yeah, so taking the time to understand the sort of procedures a little bit better, to understand how the needles are set up and how the machine runs. We did that over the next month. So as we mentioned previously, there was certain offsets in the fill weights from each of the filling needle observed across each of the batches. So what we've actually done is, again, sat down with the operators and engineers to understand, okay, how do we set them up? And the way they currently set them up is by setting up as they would do, pressures, speeds, all that sort of stuff. They then take a single measurement from each of the filling needles, and as long as that weight is within the specification, we run, which is quite, especially considering what variability is in the process.
You do need a few measurements to be able to assess the variability, but with just one single measurement, that sounds a bit unreliable. Well, I mean, if they can take more measurements, it's to get a better estimate of the variability. That would be great.
Yeah, I'm glad you've said that, because that's what we've decided to do. So what we've decided to do is take the mean of the first 5 fill weights from each of the filling needles, and as long as they're within our a sort of central range of the specification, so between 1.15 and 1.19 grams, we're good to go. And we've actually got some additional trending tools in the department as well that we've put in place to help the operators see that. So that's what we've done. So hopefully it's made a difference.
Oh, let's have a look. Oh, right. I can see there's improvement in the variability, and it seems that there's a bit more overlap with the reading from the free feeding needles there. There's still a bit of differences, but you can see they seem to follow more or less a similar pattern now, isn't it?
Mm-hmm.
And looking at the capability results, well, I can see there's an improvement because the process is more centered to the middle of the spec, or the middle between the upper and lower spec. And the PPK has improved definitely. Well, because it was just above 1 in the previous results. Now it's 1.52, so that's a good improvement. And yeah, you've got or even 0% out of spec now, so that's good to see.
Yeah, definitely been noticing the difference anyway with people. We haven't had any issues. We've had to back check anything. Everything's been running really well. Yeah, it's great that's reflecting the data.
Oh, well, yeah.
I can say actually what the teams have actually found, they've got a bit of they've gotten the bug for this, so they're really wanting to make some more improvements to it, because they reckon, certainly the engineers think, we can go a little bit further with this and make things even better.
Oh,
understanding the process a little bit more.
Well, it's I guess it's even though it's a process of filling of the filling needle, I guess there are factors affecting how the needle works, isn't it? So maybe, I'm just wondering, maybe you could do something using DOE, so do some experiments and see if there are settings with some of the factors that can help you to make improvement to the process.
That's a really good idea. Yeah, we've got probably 3 key factors I think that could impact the fill weights, and we've actually got some downtime in a couple of weeks' time where we've actually finished our schedules above time. So we're going to take some time, to maybe a couple of weeks, to run a few runs over there at different settings and see what we get. So yeah, that's a great idea.
Oh yeah, let me know how you get on.
So 6 weeks later, after the shutdown, we, working with the operators and also the engineers, we devised a factorial DOE with 3 factors at 2 different levels.
Right.
So we did that, and what we did find, was that by slightly increasing the filling pressure and also the speed of the line, we actually were able to get much more consistent filling with a lot less variability from what the runs that we did. So, which is great. So what we thought we need to do is, at them settings, run for 3 batches and see what we get after that, because we did do only short runs at the time. So it may have been, we want to make sure that we can replicate that in proper normal proper filling conditions.
Oh, right. I guess you've got some data to show, isn't it? Oh,
we have,
that
yeah.
looks some very nice data here. So, well, I can see there's a more consistency. You've got all the variability. It's much reduced with the new settings, and a very more improvement to the capability indices. Whilst you've got CPK and PPK over 2. That's good.
Yeah, it's really good. Yeah, I mean, it's we've never had it so good. It runs, and the good thing as well, actually, we've increased the speed as well. So it's actually lines running faster and it's better. So it's an absolute win-win. It's definitely, like you've mentioned there's nothing been anywhere near close to the specification limits, which is great.
Well, since the process has improved quite a lot, Is there any way that maybe you can have a look at the process and see if there's other ways where you can reduce the costs, or maybe, you know, see what else you can improve.
That's a really good idea, yeah, because there's potential. I mean, there's we're very comfortably in the specification, so would we dare lower that limit a little bit, drop it down a little bit close to the lower spec? So that if we do that, we can actually produce more.
So that, yeah.
So increase our yield. So that no, I'm not too sure. We'll have to see if we can do that. We'll
Well, yeah,
certainly we'll give it a go.
give
But
it a go and see what happens.
yeah, we'll try. We'll let the process run for a little bit, and then we might try in a couple of months' time, and we'll get back to you, because potentially that might be a fantastic thing if we can do that. We'll save a fortune.
Yeah, because if you can, increase the yield, that's always better.
Mm-hmm. Definitely. So 6 months down the line, what we've done, we've ran at the previous conditions. So again, we've got those filling parameters set. We've got them set in stone. So now we always do the same. So we always have the same setting, which is great. But now what we've actually done now is, so the previous target was actually 1.175, but what we've now done is drop that slightly down to 1.14. It doesn't seem like much, but actually what we then get is about 2,500 biles out every single time that we fill, which is
that's good.
a 3% increase in our yield, which is absolutely fantastic. And what that actually avoids us doing. So usually what we do is we make 100 batches a year, but now we can get away with only making 97 batches a year. So we save capacity in our manufacturing facility, our filling facility, and obviously it costs us a lot less in terms of cost of goods, which is fantastic. And the good thing as well, which is really surprising, is actually to make this change is really, really easy, because the only things that we've got registered with the regulatory authorities is those upper and lower limits. So we don't need to worry about re-registering the target fill weight. We don't need to worry about that, as long as the
within the limit.
Exactly, as long as we're within the limit, we're good to go. So
yeah.
I wonder what you think. Well, we'll show you what data we've got, but again, we're very confident that we should be able to stick with this.
Well, you can see it's obviously you got to move the process to be closer to the lower limit, but you're still within your target, and for the capability indices, well, you're still within an ideal ranges. Well, both CPK and PPK, they're both close to, they're both about 1.33, which is what you need anyway. So if you can get away with more yield, is always better. And I guess it's reduced the cost of the production as well. So
yeah, definitely definitely a win-win. Definitely, it's been really good. Yeah, that's great. So I suppose to summarize again, it's what we've basically gone through there is a very, very clear, a simple as well, data-driven, systematic approach to understanding our process quality, and then also to try and dictate what the next steps would be to try and improve what we've got already. We've mentioned before is what we're trying to do is trying to focus on standardization first. So like we mentioned about the measurement system, and the filling needle setup. So making sure that we do that standardization first. And again, what that has actually led to is variability reduction, because everybody's doing the same thing. Everybody's doing the same thing every day, every shift. So that then drives consistency, which will drive variability down. Say we nailed our quality performance first, make sure that everything's okay, everything's doing what it should do, and then, like I say, we've got the efficiency gains after that. So
yeah,
I think it's been a very, very worthwhile exercise. It's taken time to do it, but it's been very worthwhile doing it.
Exactly, and always, improving the process is at the end of the day, you become more efficient, and more efficient, that means is you can get more from your process.
That's great. No, thank you very much for your help.
Yeah, thank you.